And welcome back. All right, so hopefully you got through horizontal asymptotes all right. As you can tell, this part of 2.2 is taking a look at what makes a vertical asymptote. And you guys already know what a vertical asymptote is, right? You're able to say that a vertical asymptote is, something on a graph. Here's a graph, right? I come over here and I say, well, I have some funkiness going on here. I have some funkiness, I don't know, going on here, and probably here is where my vertical asymptote is. You might have an oblique asymptote, however it may work. Okay, but there's your vertical asymptote, right? It cannot cross that line. You've seen them, you dealt with them. So now what we're going to do is show what it means to be a vertical asymptote, okay, with calculus, with limits. So let's take a look at this. So a line is a vertical asymptote with a graph of a function where y is equal to f of x if either the limit of as x approaches a from the right is plus or minus infinity, or the limit as x approaches a from the left of my function is plus or minus infinity. What does that mean? Let's take a look at the example that I just showed you up here. So if I take a look at this, let's say that this line is a. Well, let's make a better a so you can see it better. There it is. So there's a. So what's the limit of my function as x approaches a from the right? So again, I'm going to take a look here. What's the limit as x approaches a from the right of my function? So here I am. I'm coming from the right. So here I am. Coming from the right, getting closer and closer to a. What's my function height going to? What's going down, 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 all the way down? How far down? Think about it. How far down? Give you hints. All the way to negative infinity. Okay. All right, so let's do the same thing. Right there, this right here, according to what this, the definition of vertical asymptote, I just showed it. I now can show calculus, with limits, that there is a vertical asymptote there. All right. So now I want to say, just to show, well, what happens as x approaches a from the left of x. Okay, so what's happening from the left? So here I go from the left. I'm getting closer and closer and closer to a. Where am I going? I'm hoping you got this and thinking positive infinity. All right, I'm hoping you go there. All right, so let's take a look, because being able to show this graphically is one thing. Well, again, the hard part here is the algebra and the thinking, the number sense that's involved. So that's what we're going to be working on next. All right, so this example. It says find the vertical asymptote of our function 1 over x squared. Describe the behavior to the left and the right of each vertical asymptote. So my steps involved in this that I want to go ahead and do is, first thing I want to do is I want to find my discontinuities. All right. That's a big word. I'm sure if I spelled it right. Continuity. I think I did. All right. Find my discontinuities. Well, what does that mean? Again, you have to be thinking, what does it mean for a function to be continuous here, right? Where do I have problems? Where in a rational function do I have problems? All right. So in this one, I'm going to have problems when my denominator is 0. In other words, when does x squared equal 0? All right. My discontinuity is going to be x equals 0. World blows up, right? All right. So that's where I have a discontinuity. So then what I want to do is I want to find out, is that discontinuity a whole, or is that discontinuity a vertical asymptote? So number 2, is it a whole? Okay, or is it a vertical asymptote? How do I figure that out? Well, the way that I figure it out is once I find my discontinuities, well, 1 in this case, my one discontinuity says, is it a whole or is it an asymptote? Well, I plug in. So I want to see, what does f of 0 look like? Well, when I plug that in, I get 1 over 0 squared, which is equal to 1 over 0. What you need to remember from our previous lectures is that if I have 0 over 0, I have a hole. But whenever you have a number, any number over 0, that means I have a vertical asymptote. Okay? Great. So now I have a vertical asymptote, and it wants to describe the behavior to the left and the right of that vertical asymptote. So my vertical asymptote is at 0, so let's go ahead and describe its behavior. So in other words, it wants me to find the limit as x approaches 0 from the left of 1 over x squared. And this is where you have to think a little bit, actually quite a bit. Okay? So you have to be like, well, what's happening? What do you mean 0 from the left? 0 from the left means what? I'm coming from all my negative numbers, right? So if you want to, you can put a little x-axis up here, right? Here's x-axis, here's my 0. I'm going to have these negative numbers. I'm coming from the left. They're going to be negative numbers. So I'm going to put in negative very small numbers. So, for instance, if I was going to find out if I'm getting closer and closer, I would have f of negative 0.1. And then getting a little bit closer at negative 0.01. And then I would get a little bit closer and I'd be negative 0.001. I have to be thinking, well, what's happening here? Well, when I do this, well, that becomes 1 over negative 0.1 squared, 1 over negative 0.01 squared, and 1 over negative 0.001 squared. Don't forget your parentheses, right? So then what happens when this squares? Well, this is going to get to a positive. This becomes a positive. And this is where your number analysis is going to become key. Well, what's happening here? Well, this value is going to be, well, 1 over, well, it's negative 0.1 squared. Okay, well, it's 0.01. Negative 0.01 squared was going to be positive. I know that. And it's going to be 0.0001. And then this one's going to be 1 over 0.1, 2, 3, 4, 5, 1. And they're all positive. So what's happening? Okay, so I'm getting a very, very small number. That number is getting smaller and smaller and smaller on the denominator. So then your number sense has to kick in. You have to say, well, what happens when I'm getting 1 over a very small number? 1 over... So to help you think about this, well, what happens if I have, let's start with 1/4, then 1/3, then 1/2? Is my numbers getting smaller or bigger? Okay, I'm hoping you see that they get bigger. In fact, as you put a smaller number in the denominator, your number is going to get bigger and bigger. And the smaller you get, the bigger it gets. And every time I get closer and closer to 0, I'm getting a bigger and bigger, a smaller and smaller number inside the denominator, which means I'm getting a bigger and bigger answer, which means that this is going towards positive infinity. And hopefully, if you'll notice that I'm not going to go through the same steps for going with the limit as x approaches 0 from the right. But if you do that, if I do the limit as x approaches 0 from the right of 1 over x squared, hopefully you'll see that this is just the same thing in reverse. I would start at, well, f of 0.1, f of 0.01, f of 0.001. I'm getting closer and closer to 0 that way. And it won't matter as much, and you should see that I would still get a positive infinity. That number keeps getting bigger and bigger and bigger. So I've shown, by just doing the first one, I've shown that it has a vertical asymptote. Here it's asked, because it asked me to figure out what was happening. So how is that useful? How is that possibly useful for me? Well, that's what the next example is going to show me. How this analysis is going to become useful. So here we go. First one. I'm going to go a little bit faster here. Hopefully you see this as a difference of two squares. So I can see p of x as being 1 over x plus 3, x minus 3. And it's asking us to go ahead and find the discontinuities. So I rewrote it or factored it out this way. So I can find that I have a discontinuity at x equals 3 and x equals negative 3. Now they want me to find the limits as x goes to the left and the right and figure out which ones are vertical asymptotes or holes or what have you. So I go ahead and take a look. I want to find my vertical asymptote, so I want to do with this one first. Then I'll come back to B. So again, when I plug in P of 3 and P of negative 3, what do I get? Well, when I plug in P of 3, alright, this gets me 1 over 6 times 0, which is 1 over 0. P of negative 3, it'd be 1 over 0 times negative 6, which is 1 over 0. I have them both being 1 over zeros or numbers over zeros, so that means that they're both vertical asymptotes. Okay. So I know I'm going to have a vertical asymptote here at negative 3. I know I have a vertical asymptote here at positive 3. So now I want to be able to do is, well, what's happening to the left and to the right of these? And this is where, again, thinking cap on. So let's take a look at negative 3. And I find out, well, when I'm at P of negative 3, what's causing my discontinuity is this piece right here, the x plus 3. Alright, notice that this piece right here, okay, the x minus 3 is not going to have a whole lot to play with this. It's just going to be a number. Alright, this is what's causing my numbers to get smaller, or, smaller and smaller and smaller, which would be bigger. So now the big thing is deciding, is it going to be, positive infinity or negative infinity? Alright, so I can look over here. If I choose stuff that's coming from the left, so if I find the limit of P of x as x approaches 3, negative 3 from the left, what do I get? Negative 3 from the left means that I'm going to be coming from over here and going, is it going to go down or is it going to go up? So that means I'm going to have like negative 3.1, negative 3.01, negative 3.001. What's happening? Is it this way, that way? Okay, so when I put in a negative 3.01, notice this inside piece will still be negative. Since it's still going to be negative, it's going to make this, means that's going to be 1 over a negative. So then I come over to here, x minus 3. So if I put a negative 3.01 into there, what do I get? Well, a negative minus a number, that also gives me a negative here. So I got a 1 over negative times a negative, which is going to be 1 over a positive number. So I'm going to get positive numbers. What does that mean? I'm going to be going to positive infinity. So that means on my left-hand side, I'm going up to positive infinity. What I'm going to want you to do next is let's take a look at then what happens the limit as x goes to 3 or negative 3 from the right of my function. So when I analyze this, negative 3 from the right, that means negative 2.9, negative 2.99, negative 2.999. When I look at this, so negative 2.99, so that means when I put negative 2.999 in for x, I'm going to end up with a positive number. This over here, negative 2.999 goes in, I'm going to end up there still with a negative number. So what does that make the value of my function going to be? It's going to be negative, and therefore it's going to be negative infinity is where my limit's going to. Alright, what I'm going to do is I'm going to pause the video for you. I want you to figure out, so my asymptote's going right here. It's going down. And I'm going to go ahead and pause the video now, and I want you to go ahead and figure out what's happening over here at positive 3. Which way are my asymptotes going? Alright. Welcome back. Here's my work. I want to go ahead and see that you should have this as it's approaching 3 from the left, it's going to be negative infinity, and as approaching 3 from the right, it's positive infinity. If you don't understand it, go ahead and pause the video and take a look at my work and see if you agree. Otherwise, we're going to keep on moving. So the last part is, well, what can I do as far as graphing this? Well, I know probably over here from looking at this real fast, I can see that my horizontal asymptotes are going to be at 0 from based on my analysis, and I can also probably see that if I go here, if I plug in 0, I'm going to get negative 1/9 as an answer, so way up here. So if I had to best guess it, I would go ahead and say this is probably happening, this is probably happening, and this is probably happening. What you're going to do is, if you want to, go ahead, go on your calculator, pause my video again, go on the calculator, graph it in calculator, see if I'm right, see if you're right, and we'll keep on moving. All right. Example number is high. It says that list any vertical asymptotes and give the limits at each point of discontinuity for this function here. Okay, again, this is where I want you to go ahead, and I'm going to pause it, and I want you to go ahead and find the points of discontinuity. Alright, taking a look at the work, I got my points of discontinuities at x equals -3 and x equals 2. So for some of you, if you went over here and crossed out the x plus 3's already, that's going a little bit too fast. You need to, for points of discontinuity, you need to look at the whole picture before you start crossing things out. Okay, so next I'm going to decide what if these become vertical asymptotes, or are they holes. So I got to go ahead and individually find out, are they vertical asymptotes, okay, or are they holes? Again, I'm going to have you guys pause the video, and I want you to go find out which one's a vertical asymptote, which one's a hole. So if you take a look at my work here, f of -3 is a hole because I get a snowman, and f of 2 is a vertical asymptote because I have a number over 0. So I can go ahead and draw that in there. That one I know is going to be a vertical asymptote. Now I'm going to go ahead and do what I want you guys to do. See here. I'm going to have a hole. Where is that hole? Remember how we found that hole location? Okay, we wanted to find out what the limit as x approaches -3 for my function f of x. That's how we found out where our hole was at. In order to do that, now we can go ahead and do our crossing out. And when you cross out your x plus 3's, you get that as being 1 over, or the limit, as x goes to -3 of 1 over x minus 2. Now I can go ahead and plug in that in, and I get a 1 over -5, or a -1/5. That means at -3, -1/5, there's a hole. So actually what I want to do is I'm going to walk you through finding out what's happening to my vertical asymptote behavior, because what I want to show you is that how this one is different. Okay, so what I'm going to have here is I want to find out what's happening at the limit as x approaches 2 from the left of my function f of x. So 2 from the left, that means like a 1.99, okay? So if I have a 1.99 and I put it in for x, alright, 1.99 plus 3 on top is going to be a positive number. 1.99 plus 3 is a positive number, times, and then 1.99 minus 2, ooh, there's a negative number. So a positive times a negative, negative. Do the division. That means my limit is going to go to -infinity. Okay, so I already knew that, and so it's going to go -infinity, boom, from the left. Do the same, similar type of a thing, limit as x approaches 2 from the right of my function is equal to, let's do the analysis again, 2 from the right, that means like 2.1, 2.11, 2.01, okay, that means we're going to go 2.01 plus 3, well, it's still positive. 2.01 plus 3, it's still positive. 2.01 minus 2, that's now going to be positive. So the whole thing is positive infinity. Okay, so one thing I'm going to leave you with, so there's that. Now as far as the graphing of it, probably, hey, here's my hole. Again, my horizontal asymptote is going to be 0 because the bigger exponent is on the bottom. There's that right there. Okay. So So what we've done the last couple of lessons here is be able to start sketching in a graph without having to use a graphing calculator, without having to find each of the values, which is what these people had to do way back in the day with before calculators. And they wanted to find a shortcut. So Sir Isaac Newton was finding shortcuts. Okay, again, math people, we're lazy. We want to do as little work as possible. Okay, and this is what we found. We found shortcuts in order so we don't have to graph point by point by point. Okay, and we were able to prove this. One of the things I want to say is, generally speaking, if you find a vertical asymptote, the one is going to go up and the other one's going to go down, unless you have x squared in there. You need to be cautious of that. Okay, the other part that I want you to take note of, okay, is look, I plugged the values in to my original function, not to the one that was simplified. You always plug it into the original function to make sure you've got everything you need to know. Okay, you don't put it into the simplified version. All right, I guess that's what I've got for you. Here comes your assignment, I believe. There it is, section 2.2, part 2. Good luck, and we'll see you tomorrow.